Good day everyone. We are the Group 5 and today we will be discussing Problem 3.5. Problem 3.5 states that a dormitory at a large university that was built 50 years ago has exterior walls constructed with the thickness of 25 mm sheathing with a thermal conductivity of 0.1 watts per meter Kelvin. During the winter, to reduce heat losses, the university decides to encapsulate the entire dormitory by applying an insulation layer with a thickness of 25 mm characterized by with a thermal conductivity of 0.029 watts per meter Kelvin to the exterior of the original sheathing. It was then covered with a glass layer with the thickness of 5 mm with a thermal conductivity of 1.4 watts per meter Kelvin. We are asked to find the heat flux through the original and retrofitted walls when the interior and exterior air temperatures are 22 and 20 degrees centigrade, respectively. The inner and outer convection heat transfer coefficients are 5 and 25 watts per square meter Kelvin, respectively. In the problem, we are given the thickness and thermal conductivities of the original wall, the insulation layer, and the glass layer. We are also given the temperatures inside and outside the walls with convection heat transfer coefficients. And we are to find the heat flux through original and retrofitted walls. The schematic diagram was shown here with where the resistances are each for a unit area. The assumptions are one-dimensional conduction, steady-state conditions, constant properties, and negligible contact resistances. To get the heat flux, which is heat rate per area for the composite wall, we will use the equation 3.15 in the book and just plug in the data, and then we arrived with the final answer of 30.982 watts per square meter. This is the heat flux that passes through the original and retrofitted walls. That's all for problem 3.5 and thank you for listening.